Hello friends, welcome to our channel QT and Quick Technical Notes. Friends, today we'll discuss on very important ophthalmic machine Optikon. So friends, as you can see the picture, it is Optikon is a machine that is performed and functionality in a convenient, compact, modular design. So you can see the picture of the machine, how it look likes, and we will highlight some point of display panel. So the display panel you can see here we have ultrasound. Under ultrasound, this category we have linear, pulse, auto limit, and we have reset option also. In second case we have in right hand side we have pulsed. In this mode we have category we have high, STD, cold, eye ice cold, and next we have agile irrigation mode. You can see friends the display panel how it's look like. We have the peristaltic pump here, function of peristaltic pump, fixed flow and aspiration. So in aspiration we have vacuum linear, we have fixed vacuum flow fix, and as you can see the picture, there is a option of priming. Before starting the cataract surgery, we have to perform the priming of the machine, then coagulation, and the steps, important steps are coagulation, sculpt, quadrant, epinucleus, cortex, polishing, visco, anterior vitrectomy option. So this is all about Revo Smart Opticon Phaco machine. So we will discuss the important points today of the machines. So important point is agile, fluidic, fluidics, uh, active irrigation system, and dynamic IOP control. This is the main function of the machine: active irrigation system and dynamic IOP control. The advanced microprocessor control active irrigation system, linear increase and decrease pressure in the irrigation solution container up to maximum 20 mmHg to compensate for intraocular fluctuation caused by vacuum up to a limit of 400 mmHg. Very important point. Active irrigation system and dynamic IOP control act synergistically to mitigate surge. So we have program IOP here. You can see the picture, and here we on the right hand side we have dynamic IP compensation graph between the pressure in the bottle mmHg and graph between vacuum generated by aspiration mmHg. So this is the graph. You can see the picture. Now we have IOP management. So in IOP management, the control the IOP 34 mmHg vacuum 600 mmHg control is off. In this off control, the IOP mmHg and the time per second graph showing that aspiration is on in this process, and in this process the aspiration is off. So and control is off. When control is on, it look like this: aspiration on and aspiration off. The graph between the IOP mmHg and time per second. So the as you can see the picture, the above chart shows the IOP fluctuation under active aspiration without an IOP control system. In this case, right hand side, the chart shows a constant IOP value even under active aspiration with the dynamic IOP control system. So this is very important point. With our evolution smart, a programmable 4 pole is IV pole is provided with the optional chart. Next we have, friends, interchangeable flow and vacuum pump. So selectable aspiration between flow, peristaltic or vacuum based venturi pump. Interchangeable flow and vacuum pump only for our evolution smart S and R evolution smart CR. So these are the important features of this machine. The flow range is 1 to 65 cc per minute. Vacuum range is 5 to 650 mmHg. So you can see the chart of the machine which we have discussed earlier, display panel, and here you can see the vacuum range 5 to 650 mmHg and selectable vacuum rise time slow or fast. It is shown in this display on right hand side. So friends, our next important feature of this machine is optimized energy management. So optimized energy management, it is a minimum stress technology. The what is this technology? The patented minimum stress technology is the only system on the market that uses a feedback control energy delivery to piezoelectric crystal in order to maintain the exact tip stroke set point even under the load condition. Very important point. So minimum stress technology optimized US energy delivered, always ensuring consistency between the programmed and actual Phaco tip stroke regardless of nucleus hardness. So next we will discuss about the traditional US delivery technology. You can see this part where tip elongation programmed is not equal to actual. You can see this uh, where tip elongation program not equal to actual, but on the other hand you can see the on right hand side we have BVI minimum stress technology US delivery technology tip elongation programmed is equal to actual. So this is our in blue color, dark blue color, the program tip allocation indicate the program tip allocation and actual tip allocation in the light blue color, sky blue color. So here you can see the tip allocation program is equal to actual. It is equal to actual, but here is a difference between the tip allocation programmed not equal to actual. So friends, we have next we have stroke microns versus time seconds into 100 stroke microns. In case of in our this case we have graph like this, and in the next case we have graph like this, the stroke microns and between the stroke microns and time. So in this case, no consistency between the program Phaco tip stock and the actual tip allocation. When the Phaco tip faces the resistance present by hard lens material, And on the other hand, looking on the right hand side, we have maintained consistency between the program Phaco tip stock and actual tip elongation. When the Phaco tip faces the resistance presented by a hard lens material. So, friends, other feature of this machine we'll discuss that it has a LED light system. You can see the display where we have the filters green, 432 nanometer, 435 nanometer, 475 nanometer, 515 nanometer. We have these wavelength lights. So the complete R evolution smart CR unit is equipped with two independent high efficiency LED light source free of harmful ultraviolet and IR emissions. The LED light system allows surgeon and enhance to tissue visualization and guarantees the maximum protection against the phototoxicity. In order to improve the contrast and ocular tissue visualization during VR surgery, both LED sources have four different selectable filters: three yellow, 435 nanometer, 475 nanometer, 515 nanometer, and one green. So this is all about the feature of the machine. Next feature is full control foot pedal. So you can see the picture of foot pedal. We have one function here, one mode, non. We have reflex this side, US cut this side, US aspiration this side, upward. We have here load, saving option also here. We have paddle, we have language, we have import export option. And friends, we have the compact and lean R Revolution Smart Foot Pedal offers a streamlined programmability and accurate response. The foot plate features an integrated heel support that facilitates dual linear control, allowing simultaneously vertical and yaw control. So, friends, this is all about. We have the integrated solution for vitreoretinal surgeries. You can see the picture. We have vitro vitrectomy probe, single blade vitrectomy probe. We have twitch vitrectomy probe, and the twitch is 20,000 cuts per minute. Dual blade vitrectomy probe. This is the feature, very important feature of the machine. First dual blade vitrectomy probe ever marketed, even close to retina. Short tips to for distance and enhance retinal saving action. So you can see the 23 gauge, 25 gauge with 33 mm dia with 28 mm dia. So integrated solution for vitreoretinal surgery is optimized vitrectomy fluidicides and with the twitch vitrectomy probe. Constant flow at any cutting edge. The chart shows the difference aspiration flow achieved using the twitch vitrectomy probe solid line compared to single blade vitrectomy probe dashed line as a cutting rate changes. In particular, the solid line shows how the flow remains constant up to 20,000 cuts per minute with the twedge vitrectomy probe. In the comparison, the flow decreases as the cutting rate increases using the single blade vitrectomy probe. So friends, you can see this graph of aspiration flow versus cutting rate cut per minute. This is how the graph is flowing, where 23 gauge twitch, this is a graph of 23 gauge twitch, and this is a graph of 23 gauge single blade cutter. So balanced salt solution vacuum is 650 mmHg and Venturi pump R evolution CR. Next we have enhanced stability even close to retina. The chart shows the accelerations induced by the twitch vitrectomy probe solid line and the single blade vitrectomy probe dashed line as function of the time. At even blade work cycle, the reduction of stress value using the twitch generates a pulse free action and the outmost safety close to the retina. The twitch vitrectomy probe leads to significant reduction of stress value, generating a pulse-free action close to retina. So by the graphs, you can look the graph. It is a 23 gauge twitch and difference between the 23 gauge single blade cutter. This is the graph of single blade cutter, orange color, and the green color is the graph of 23 gauge twitch versus acceleration versus repulsion. So friends, this is all about the features of the machine we have discussed today, and have a look about the display again so that we can recall the things. In display we have ultrasound, we have pulsed, we have agile, we have irrigation, we have peristaltic aspiration. And the steps for Phaco emulsification after priming is coagulation, scalp, quadrant, epinucleus, cortex polishing, visco, and anterior vitrectomy. So this is all about Revo Smart Phaco emulsification machine Optikon. Thank you for listening. Thank you very much.